Block 2. Welcome to my YouTube channel, Miss P Does Math. If you haven't done so already, you should have answered the attendance question on the stream on Google Classroom. Make sure you're answering the attendance question each day because your teachers are taking attendance. If you don't answer, you'll be marked as absent. The other thing that you should have done is you should have read the feedback on your assignment from yesterday if you submitted it, and look at the answer key that was posted to the stream. Again, that's only visible to you if you submitted the assignment, so make sure you submit that as soon as you can. What you need for this lesson is either a printout of the 10.1.4 packet that was attached to the day 8 post and the 10.1.4 summation notation notes. If you don't have a printer, that's okay. Just make sure you're working on line paper. So right now you should be taking notes on line paper in your math notebook. We're going to be learning something new called summation notation. It's related to everything that we've been doing anyway. So far, you should have already completed all of 10-51 and just letter A of 10-59, and we're going to pause right here, and you can't continue on until we do these notes. So here you should have been introduced to summation notation already. It kind of looks weird. Some of the parts look familiar, and you're just supposed to kind of, decipher maybe what each part means. So this should be filled in. Make sure everything is filled in so that you do get completion credit. So here we'll get started. 10.1.4 summation notation notes. So far we've been learning about sequences. Sequences are a list of numbers separated by commas. An arithmetic sequence is a list of numbers with a pattern of addition or subtraction to get to the next number. In the same way, an arithmetic series is the same thing. The way to get to the next number is a pattern of addition or subtraction. It's consistent addition or subtraction. The only difference is instead of commas, you have addition signs. So you are finding a sum for a series. The way that you represent a sequence is with your explicit equation, and we've been doing that so many times where you make the t of n, it's like y equals mx plus b. You have your pattern times n plus the 0th term, or you can use the version with the first term that we took on the notes the last time I saw you in school. The way that you can represent a series is with summation notation, and once you see summation notation, you know that you are finding a sum. So the capital Greek letter sigma, just fill these in, equivalent to capital S in English, is used in mathematics as a shorter way to indicate the sum of a series. It's just notation. For example, here you have your capital sigma. It shows that it represents a series or a sum. We have an n equals 1 on the bottom. You'll see that for most, if not all of these, it'll always have n equals 1 at the bottom. Then you have a number at the top, which is 5. And here you have something that looks like your explicit equation, and that's exactly what it is. It's just that you don't see the t of n equals. It kind of just has the main part of it, the 2n minus 3. And then it's equal to, and then you have this whole list of numbers with the plus signs in between, and you get the 5 because 1, 2, 3, 4, 5, that's your n. You were just adding up the first 5 terms, and then if we just actually add those, -1 plus 1 plus 3 plus 5 plus 7, without the equation, you can just plug this into a calculator and you get 15, or do it in your head. So translated, this expression means the sum from n equals 1 to n equals 5, so the sum of the first 5 terms of 2n minus 3 is just equal to 15, and that's how you notate a series. We call n the index, and 2n minus 3 is the argument, and that's just another word for your explicit equation. Just make sure that you don't need the t of n in there. The values of the index are consecutive, positive, integers, only. So the values of n in the example above are 1, 2, 3, 4, 5. We've mentioned this before, that n is always the numbers 1 through infinity, and they're always positive, and they're whole numbers. I've commented on some of your assignments the past week or so that if you're getting n's that are decimals or that are negative, it doesn't make sense. It doesn't make sense to say that the -6th number in a list is so-and-so, or the 80.5th number in a list is so-and-so. Your n's should always be consecutive, positive, and whole numbers. So 1, 2, 3, 4, 5 for this example. You could obviously go above, but it did say 5 in this example, so we stopped at the 5th term. So now we're just going to kind of use this notation and vice versa, find the sum, write out the list of numbers with the addition signs, put it back in summation notation, and so on. So use summation notation to represent the following series. So in letter A, we have 1, 3, 5, 7, 9, 11, 13. So we're just going to draw our big sigma. At the bottom, we always have n equals 1. That just shows that we're starting to add from the first term. At the top, we always put our n. So how many terms are we adding up? 1, 2, 3, 4, 5, 6, 7. And then all that's left to do is your argument, which is your t of n equation, except you don't need to write t of n equals, just write the main part. So the pattern is always the slope, so I can see that I'm adding 2, so that's 2n. Now if 1 is my first term and my pattern is adding 2, I have to subtract 2 to get my 0th term, so that's -1. So that's it. That's this all in summation notation. So if someone were to say this, they would just plug in, you know, if they were to see it, just plug in 1, 2, 3, 4, 5, 6, 7, and they get this whole list of numbers with the plus signs in between. Let's do the same thing for letter B. We have way more numbers. So our sigma show that we're going to start adding from the first term. At the top goes the number of terms that we're adding up. That's our n. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then to the right is our argument, which is just the t of n equation again. So I can see here that my pattern is adding 4. That's 4m. So if I'm adding 4, I subtract 4 to my first term to find the 0th term. That's -5. So that's basically how you take your series, the list of numbers with the addition signs, and put it into summation notation. So let's do like vice versa. If they give us the summation notation, how do you write the series? So basically you can just, you know, do the same thing as if you were missing information when you're finding your sums. Like if you're missing your term, you would just plug in 1 for the first term, plug in 2 for the second, 3 for the third, and so on. And we're going to stop at the 6th term. And you don't need to find the sum. We're just going to write out the list of numbers with the plus signs. So if I plug in 1, I'm just going to show my work here. I see that my first term is -2 plus 7, which is 5. If I plug in 2, I get my second term, which is -4 plus 7, which is 3. And you can just keep plugging in 3. So that'd be -6 plus 7, which is 1. And then you can plug in 4, 5, and 6 for your 4th, 5th, and 6th term. Another way to look at it is, well, if 5 is my first term and my next is 3, I know that my pattern is subtracting 2. So you can kind of just continue the list by subtracting 2. So 3 minus 2 is the one that we got as the third term. Keep subtracting 2. And you get -1, subtract another 2, and you get -3, subtract another 2, and you get -5. So those are 2 ways that you can continue your list, by either plugging in or just continuing the pattern. And I'm just going to put my plus signs here. You can put plus signs here if you want, but adding a negative is just a negative, so I'm basically done. Here's my list of numbers with the plus signs in between, and it's the first 6 terms. Perfect. Okay, so now we're going to flip to the back and do some examples where you actually have to find the sum now. So in the directions it says find the sum of the series using the sum formula. So again, here's my information. I'm adding for the first term onto the 4th term, so the first 4 terms. And again, you need your A1, your AN, and your N. So I know that my N is 4 because that's the number at the top. I'm adding the first 4 terms. I know that my A1, I can just plug in 1 to get my first term. That's -1 plus 43, which is 42. And I need my last term in the list, which is the 4th term. So that means I can just plug in 4 right now. So -4 plus 43, and that's 39. I had 2 missing pieces of information, but I can just plug in 1 and plug in 4 to get them. Now that I have all of my information, I just can plug into the series formula. So S sub 4 is 4 times 42 plus 39 all over 2. And if you plug that into your calculator, you just get 162. That's done. We're just going to do one more. So you need your A1, your AN, and your N again. If this one, we're adding up way more numbers. It says 200 at the top is our index. So 200. Our A1 is what we get when we plug 1 into the argument, which is the same thing as our T of n equation. That's 2 plus 5, which is 7. And then our AN is our last term in the list, which is the 200th term. Just plug in 200. That's 405. So again, I had the 2 pieces of information missing, but I got them by plugging in 1 and 200, and now I can plug into my series formula. S sub 200 is 200 times 7 plus 405 all over 2. Plug that into your calculator and you get 41,200. So that's basically it for summation notation. It looks scary, it is new, but it basically just represents a series. Just plug in the numbers 1 through whatever. It tells you at the top the n. And if you want, you can also continue the series by just continuing the pattern if you have to make the list of numbers with the plus signs in between. Right now, you're just going to continue with the packet. So you're going back to 10.1.4 and you're starting at B right here and you're working with summation notation. You're basically going to be asked the same problems that we've been doing for over a week now. It's just that some of them are going to have summation notation right now. So again, you have 2 days to complete this. Go all the way through to the review preview, and you are submitting this by Thursday, April 2nd at midnight. If you have any questions, you can comment down below in the YouTube video or on Google Classroom on the stream or the assignment posting. And make sure that if you're on line paper that your work is clearly labeled with the problem number and the letter that you are on. Show all your work and use your notes. Thanks, and have a good rest of your day. Bye.